Let's get started. So if you look at the problems that we have this week, I tried to choose some questions from the TATs just to see if you guys are able to do a small revision on this as you're getting closer and closer to the exams. Okay, so let's go through these questions. So if you look at the first question, they tell you find the equation of the tangent line to the curve that is given by these parametric equations at t is equal to 1. And they tell you to do it without eliminating the parameter t, right? So how do you do that? You know that the equation of the tangent line is given as y minus y1 equal to m, which is the slope, x minus x1. Okay. And the question is, how do you find m? M is your slope, and that is just dy over dx. But remember, dy and x and y are given in terms of t. So this is just the same as dy over dt all over dx over dt, right? Hopefully that makes sense. So then you need to find what is dy over dt. So dy over dt is given to you as the derivative in terms of t of e to the negative t, which is just minus e to the minus t, right? Hopefully that's clear for you guys. And then also we have dx over dt, which is just the derivative in terms of t of e to the t, which is just e to the t. So in other words, we have negative e to the negative t over e to the t, which is just minus e to the minus t multiplied by e to the minus t, which is just minus e to the minus t squared. Okay. Oh, sorry, not t squared, it would be 2t. 2t, yeah. E to the minus 2t. So then we need to evaluate this at t equal to 1. So when t is equal to 1, what do we have? We have the slope equal to minus e to the minus 2 times 1, which is e to the minus 2. Our dy over dt is equal to minus e to the minus 1, and our dx over dt is equal to e to the 1, which is just e. So writing down our equation now for our tangent line, we have y minus y1, which is this, minus e let me check something. Yeah, so I'm sorry, just give me a second to double check something. Yeah, so y minus e to the minus 1 equal to the slope, which is minus e to the minus 2 multiplied by x minus e. If you expand this, you have y minus e to the minus 1 equal to minus e to the minus 2x plus e to the minus 1, which if you take the e to the minus 1 to the right hand side, you should have y equal to minus e to the minus 2x plus 2e to the minus 1. Okay, and this is the equation of your tangent line. So now, feel free to stop me at any time if you have questions, or type them in the chat box. I'll have it open in front of me so I can see. So then, by eliminating the parameter, how do we do it? By eliminating parameter t. So to do that, we know if x is equal to e to the t, right, which is what we're given, and y is equal to e to the minus t, you know that this is just the same as 1 over e to the t, right? And we know that e to the t is x, so this is the same as 1 over x. So now we have the equation of y in terms of x. Sorry, just give me a minute. Right. And then, since we have y in terms of x, we can find out what is dy dx. Easy. Just take the derivative of 1 over x in terms of x, which is minus 1 over x squared. Okay. So now we have our slope. But remember, we are told to evaluate this at t is equal to 1. And that means that if t is equal to 1, x is equal to e to the t, which is e. And y, the same way, y is equal to e to the minus 1. And the slope, which is that, is equal to minus 1 over e squared. We have everything we need. We write our equation now as y minus e to the minus 1 equal to our slope, which is minus 1 over e squared times x minus e. And that is just y equal to e to the minus 1 minus x over e squared plus 1 over e, which written a different way is just minus e to the minus 2x plus 2 times e, 2 times 1 over e, which is 2 over e, which is the same as minus e to the minus 2 times x plus 2 times e to the negative 1, which should be our final answer. Any questions on this so far?
No questions.
All right, thank you. So moving on to the second question. Now we're told to determine all the values of t for which the curve that is given there by those two parametric equations has first a horizontal tangent line. So let's look at A, horizontal tangent line. Right. How do we find that out? Well, for a horizontal tangent line, if you think about it, the curve can look whatever. A horizontal tangent line would be a tangent line that is straightly horizontal, right? So looking like that. And in other words, if you have a tangent line that looks like that, and these are your axes, that means that technically the tangent line is not changing in the y direction. It's only changing in the along the x direction. And by definition, that means that, in other words, dy dt is equal to 0, right? Because our tangent line is not varying in the y direction. It's only varying in the x direction, okay? That's for the case where you have a horizontal tangent line. In other words, to find all the points that would make that equation a horizontal tangent line, or at least that curve to have a horizontal tangent line, you would have to find all the points that make dy dt equal to 0. In other words, what is dy dt? Derivative in terms of time of t squared plus t plus 1 has to be equal to 0. And what is that derivative? That is 2t plus 1 equal to 0, which means t is equal to minus 1 over 2. So the value of t that would make our curve have a horizontal tangent line is that value. In other words, now let's look at B. When we have the case of a vertical tangent line, what do we have here? That's when now, again, using the same logic, you have a curve that looks like that. These are your axes. That would be a tangent line that is straight down like that, right? Obviously, the curve can change over time. You know, it could be something like this, something like that. And this would be your vertical tangent line. Now, the tangent line, if you look, it doesn't change in the x direction. It only changes along the y direction. In other words, for a vertical tangent line, dx over dt has to be equal to 0. In other words, the derivative over time of 2t cubed minus 15t squared plus 24t plus 7, that has to be equal to 0, which means 6t squared minus 30t plus 24 has to be equal to 0. You divide by 6 on all sides, you have t squared minus 5t plus 4 has to be equal to 0. Now we can solve for t. This is a quadratic equation. If you solve for t and you factorize, you will find that this is the factor that you find, t minus 4 times t minus 1, which gives you two values of t when t is equal to 4 or when t is equal to 1. So these are the two values of t that would make our curve, which is given to us, to have a a vertical tangent line. Right. Okay. Let's move on to the next one. If there's no questions.
There are no questions.
Right. So moving on to the next one. Now we're looking at um the length, calculating the length of each of the cycloids parameterized by these parametric equations here for t belonging to the interval from 0, closed interval from 0 to 2 pi. So again, the formula for the arc length is given as L, integral from a to b being the boundaries, the square root of dx over dt squared plus dy over dt squared dt. So that's what we need to do there. How do we do that? Well, we're given x is equal to t minus sine t. So dx dt is equal to the derivative over t of t minus sine t which is equal to 1 minus cos t. All right. And then our derivative of y in terms of t is equal to just the derivative in terms of t of 1 minus cos t, which is equal to sine t. Hopefully I'm making sense there. So then we need to plug these two under that square root, and we have our length equal to the integral. We're given the boundaries 0 to 2 pi, right? They're given here. So it's from 0 to 2 pi square root dx over dt, which is 1 minus cos t squared plus sine t squared, all under the square root dt, which, let's simplify, this is equal to the integral from 0 to 2 pi of the square root of 1 minus 2 cos t plus cos squared t plus sine squared t, all under the square root dt, which further simplified is the integral from 0 to 2 pi of the square root of cos squared plus sine squared is 1. So that would be 2 minus 2 cos t, right? Because you would have the 1 from there plus that's 1 here. That gives you 2 minus 2 cos t dt. And how the way we solve this is we can get rid of the 2 first because it's a common factor and we don't need it to integrate. So we get rid of the 2 from under the square root sign. We'll have square root of 2 multiplied by the integral from 0 to 2 pi of square root of 1 minus cos t dt. So the way we solve this is by using our half angles. Okay. So if you go back to our equations for our double and half angles, you know that cos of 2a is equal to cos squared of a minus sine squared of a. And cos of a, which is the same as cos of 2 times 1 over a, or rather, sorry, 1 over not 1 over a, but a over 2. Sorry. That is the same as cos squared of a over 2 minus sine squared of a over 2. So that's the logic that we use here. So if we use this identity and substitute it onto the square root, we have the square root of 2 multiplied by the integral from 0 to 2 pi of the square root of 1 minus cos squared of a over 2 minus sine squared of a over 2. Not a, should be t. Sorry. T dt. And let's simplify. We have square roots of 0 from of 2 multiplied by the integral from 0 to 2 pi of the square root of 1 minus cos squared of t over 2 plus sine squared of t over 2 dt. That is equal to square root of 2 multiplied by the integral from 0 to 2 pi of 1 minus cos squared is sine squared. So we have sine squared of t over 2 plus sine squared of t over 2 dt. And that is equal to the square root of 2 multiplied by the integral from 0 to 2 pi of 2, the square root of 2 sine squared t over 2 dt. Again, we get rid of the 2 next to sine squared, and we have now square root of 2 outside multiplied by the other square root of 2 multiplied by the integral from 0 to 2 pi of the square root of sine squared of t over 2 dt. Okay. Sine, and the square root of sine squared is just sine. So we can integrate this. This is equal to 2 multiplied by the integral from 0 to 2 pi of sine of t over 2, basically, dt. And the integral of sine is minus cos, but because we're dividing by, it's t over 2, we need to multiply it by 2, so it makes sense. So we will be 2 multiplied by 2, or minus 2 cos of t over 2. This is all evaluated between 0 and 2 pi, which if you substitute, you should have minus 4 times cos of 2 pi over 2 minus plus 4 cos of 0. Basically, cos of 0 is 1, cos of pi is minus 1. So we have negative 4 times minus 1 plus 4, which is 4 plus 4, which is 8 units squared. Because remember, sorry, not 8 units squared, but 8 units. Okay, because it's a length, so it's not squared. Hopefully that makes sense. Right. Then moving on to, there's no questions. Moving on to the next one. We are dealing here with obtaining the length of the asteroid parametrized by these equations here, the parametric equations, when t belongs to from 0 to 2 pi. And they give us a hint to consider the length of the piece in the first quadrant, which is this piece here, and multiply the answer by 4, which would give us the length of the entire thing. In other words, our formula for length will be 4 multiplied by our integral. First quadrant means that we're going from 0 to pi over 2 of the square root of dx dt squared plus dy dt squared dt. All right. So what is our dx dt? Our dx dt is given by the derivative over t of cos cubed t, which is just 3 times the derivative of cos, which is minus sine t, times cos cubed minus 1, which is cos squared t. In other words, this is equal to minus 3 sine t cos squared t, and the derivative of y in terms of t is equal to the derivative in terms of t of sine cubed t, which is 3 cos t times sine squared t. Again, we have minus 3 sine squared t cos t. We have our dx, we have our dy. Now we substitute that into the square root. Okay, so what does that give us? There's no minus here, just 3. This gives us L being equal to 4 times the integral from 0 to pi over 2 of the square root of dx dt squared, which is minus 3 sine t cos squared t all squared plus 3 sine squared t cos t all squared dt squared is what we have. We have 4 multiplied by integral from 0 to pi over 2 of the square root of 3 squared is 9. So we have 9 as a common factor there, taken out, multiplied by sine squared t cos to the 4t plus sine to the 4t plus, multiplied by cos squared t. Okay, dt. We can get rid of the 9 because it's a constant. We'll remove it from under the square root sign. We have 3, so it's 4 times 3 multiplied by the integral from 0 to pi over 2 of the square root of. Now, sine squared times cos squared is a common factor between these two terms. So we can take that out, and we have sine squared t cos squared t multiplied into cos squared of t plus sine squared of t dt outside. And we know that that is equal to 1, cos squared plus sine squared. So this integral becomes 4 times 3, which is 12. Let me just write 12, multiplied by the integral from 0 to pi over 2 of the integral of basically sine squared t cos squared t dt, which if you take from under the square root is equal to 12 multiplied by the integral from 0 to pi over 2 of sine t cos t dt, which we can solve by using our double angles. Oh, in fact, we can solve it different ways. We could use substitution or double angles. I'll just use double angles, but you could also use substitution here. So 12 multiplied by the integral from 0 to pi over 2 of basically sine 2t over 2. Because sine 2t is sine t cos t. 2 sine t cos t. They are divided by 2 to get rid of the 2. This is what we're integrating. So the 1 over 2 can come out of from under the integral, and it divides the 12. So we have 6 multiplied by the integral from 0 to pi over 2 of sine 2t dt, which is 6 multiplied by minus cos 2t over 2. Okay. All evaluated between 0 and pi over 2. And that gives us what? Gives us the 6 divided by 2 again gives you 3 multiplied by minus cos of pi minus cos of 0. Cos of pi once again is minus 1. So we have 1 plus 1, which is 2. So 3 times 2, which is 6 units. And that is our length. Hopefully that makes sense. Right. So that's basically it from my side. That is what I wanted to sort of give an overview of. The last problem, I think it's a bit of an easy one because it's more of a conversion between rectangular and rectangular coordinate and polar coordinates. And I guess we can cover one, just sort of give you an idea of what to do. Let's look at first 1, the point 1, here. I tell you to obtain the two pairs of polar coordinates for the points that are given. One pair that will satisfy this condition, the fact that theta, not phi, theta the angle is between 0 and 2 pi, and the case where theta the angle is between is negative, basically minus 2 pi and 0. So what are the equations that you need to know for polar coordinates and Cartesian coordinates? X is equal to r cos theta, y is equal to r sine theta, and x squared plus y squared is equal to r squared. These are the three equations that are very important. Now, you can find out what is r because you have x and y. So r is just the square root of x squared plus y squared, which is the square root of 1 squared plus 1 squared, which is the square root of 2. That is our value of r. And theta, because we know since x is equal to r cos theta, it means that theta is just cos inverse of x over r. In other words, cos inverse of x, which is 1, divided by r, which is root 2, which is cos inverse of root 2 over 2, which for our first case, right, case 1, where r is greater than 0 and theta belongs to the integral between 0 and 2 pi, that means that our theta, which is equal to cos inverse of root 2 over 2, is just equal to what? An angle that is, because the cosine is positive, so you find an angle that has the cosine of root 2 over 2, and same sign, I can think of pi over 4, for example. Pi over 4. So in our first case, we have the polar coordinates root 2 pi over 4 in the form of r theta. For the second case, that is when we satisfy the condition of r being greater than 0 and theta belonging to negative 2 pi to 0. Right. In that case, now we need to find out if we know that theta is the angle between negative 2 pi and 0, that would mean instead of going, because if you look at trigonometric circle given to us as that, and we go counterclockwise to go from 0 to pi over 2 to pi to 3 pi over 2 to 2 pi, we go clockwise. And in that clockwise direction, our pi over 4 is somewhere here. So this is our pi over 4 in the middle of the first quadrant. So then, if we're going from 0 to 2 pi, then our angle is pi over 4. But if we're going from negative 2 pi, which is in that direction, now, it turns out that our our angle theta is not now pi over 4, but it's either pi over 4 in the negative direction, which would be, if we're going that way, it would be negative 2 pi plus pi over 4. So in other words, theta will be negative 2 pi plus pi over 4, which would be minus 7 pi over 4. In other words, our notation, which is r theta, now becomes root 2 negative 7 pi over 4. Right? Hopefully that makes sense. And the same logic now applies to the other two cases where we have 2 root 3 and minus 2 and minus 8 and minus 8. Okay, so hopefully that makes sense. That is it. Yeah, that is it for me. And I'll let you continue to do the other ones while I'll try to make this this recording available. Thank you for joining.